Okay, we're going to continue our discussion about energy, and now we're going to take a little bit closer look at temperature and heat. This will be a pretty short vodcast, just going into some of the details we've already talked about. Okay, as we've mentioned before, kinetic energy and temperature are directly related. And what we're going to talk a little bit about is Kelvin temperature. We've talked mostly about Celsius so far, but now we're going to start talking about Kelvin. So anyway, all this slide is saying is that kinetic energy and temperature are directly proportional. And as we've mentioned before, that means that a substance at 200 Kelvin has twice the kinetic energy as something at 100 Kelvin. And this is important to remember, that as we're talking about temperatures, that is directly proportional to the temperature. So as molecules move faster, that means they have a higher temperature. As they move slower, that means they have a lower temperature. And remember, temperature is nothing more than a scale that humans have devised to talk about hotness and coldness. It's basically a scale of kinetic energy. Okay, let's just review our concepts of heat and temperature, the difference between the two. As we said in a previous podcast, heat is the transfer of energy from one system to another. And we always go from hot to cold, never cold to hot. And that will be important as we talk about physical systems and chemical systems. And as we've said a number of times now, temperature is that measurement of hotness and coldness. So the question becomes, which has more heat and more temperature? A cup of coffee at 110 degrees Celsius or a swimming pool at 90 degrees Celsius? So the cup of coffee has a higher temperature than the swimming pool, but the swimming pool is going to have more heat. In other words, it could transfer more energy from its system than the cup of coffee can, and that's because the system is bigger. So temperature, again, that measurement of kinetic energy. Heat is the transfer of energy, and sometimes we think of it as the amount of energy that could potentially be transferred from a system to another. So it's important to just realize the difference between heat and temperature. Okay, as we talk about temperature, mostly we've talked about degrees Celsius. But let's talk about absolute zero for a second. And I think we've mentioned this in a few other vodcasts, but let's just solidify it now. Absolute zero is that point where kinetic energy is zero. In other words, where your molecular movement is zero. Even in a solid, that molecules seem to be, or I should say atoms seem to be stationary, those atoms are still vibrating back and forth ever so slightly. So there's movement. So as you add kinetic energy to that, they move more and more and more and more, and then eventually they go into the liquid phase. But at absolute zero, there's no molecular movement. And as we've mentioned, temperature is a direct result of how fast molecules are moving. Please don't look at the grammatical structure of that sentence. Okay, so the conversion between Celsius and Kelvin is rather simple. It's a difference between 200 and 73. I think it's 273.15, but using 273 is perfectly acceptable. So if you're trying to find the Celsius temperature from Kelvin, you're simply going to take your Kelvin temperature minus 273. And if you're trying to find Kelvin from Celsius, you're going to take your Celsius temperature and simply add 273. This will become more important when we talk about the gas laws, but there are instances in this unit where we talk about the relationship between pressure and temperature when we talk about changes of state with energy. So it's important to understand the difference between Celsius and Kelvin, what Kelvin temperature is, and also that conversion. Okay, that's it for this podcast. It was a nice short sweet one where we just discussed heat, temperature, Kelvin, and kinetic energy.